Welcome back to another weekly episode of Fireside Chats with our Tigera CTO, Christopher Lowenstope.
There should be a fire back here, right?
There is a fire back there. Who we're very excited to have back after vanishing mysteriously yesterday. Thankfully, we had a guest speaker, Dr. Sanguineri, who came in and bailed us out. So if you missed yesterday's webinar, I definitely recommend that you check it out on our website. We also have a very special guest speaker or presenter panelist today, Doug Barth, who is the co-author of Zero Trust Networks, which is actually a really good topic. Yesterday was about how do you build trust inside the company and work together. And now I think we're going to well, how do we actually build a network where there is no trust or zero trust, if you will. And with that, I'm going to turn it over to Christopher and Doug to kind of get this kicked off.
Okay, so I think this was, I think for us, really interesting. We've been talking about a lot of the principles of zero trust networking with Calico and Tigera for a while now. It's been one of our guiding principles is that nothing in the infrastructure should be trusted. No endpoint should be trusted. You need to protect everything, but you also need to assume that everything's a bad actor. So we had the opportunity to have Doug on the webinar to discuss the book, Zero Trust Networking. Everyone should read this. This is a very nice coverage of the material. We jumped at it. So with that, why don't we turn it over to Doug. Doug, why don't you tell us a little bit about where you are and what you do? And
Sure. Yeah, thanks for having me. So I'm a SRE at Stripe. I work on a team that they call Compute, which is probably like the lowest layer of infrastructure in all of Stripe. Stripe's business is built on AWS. So we're not managing like hardware, we're not like actually racking machines, but instead we're just like managing virtual machines and giving like the execution environment for Stripe. So obviously like security is a very strong consideration in everything we do, somewhat like annoyingly so because it makes us go a lot slower than we'd like to go, but it's good. It's like it's a good forcing function. Before Stripe, probably the most similar experience I had was working at PagerDuty. I was one of their first few operations hires. So I helped replace their database, encrypt all of their network traffic, did disaster recovery work, and really like got my my feet wet on doing like this type of work. Because before that, I used to be a Chicago area resident and worked at like startups and Orbitz.
okay.
Started doing product development. At Orbitz, I got to do a bunch of different things, led their like development tools team for a while. I did a project that, if anyone's ever heard of like Graphite, like Orbitz did this project way back when that was about like redoing all of their instrumentation monitoring. And so I was on the team that helped do that. I worked on like the API that people would instrument their code with so that we could like literally just have like pervasive tracing throughout the system.
Very cool. Very cool. So you did the Zero Trust book while you were at PagerDuty, correct?
Yep.
So why don't you talk to us a little bit about what got you thinking about, first of all, did you know about the term Zero Trust Networks or the concepts before you started working at PagerDuty, or was this something that sort of you developed while you were at PagerDuty?
Sure. So we definitely did not know about the concepts or terminology of Zero Trust Networking. We just kind of like fell into it. So PagerDuty was an interesting organization to work at from like a systems design perspective, mostly because PagerDuty early in its company history had decided that reliability was one of the key non-functional requirements that their customers demanded of them. So that forced them into a system architecture where they were multi-region a lot earlier than most companies would think about doing that. And so when we were working on the system, that ended up meaning two things. One was all of the intermediary networks between our systems were completely untrusted. PagerDuty was also like a cloud-hosted system. And then two, the like reliability is only as useful as like the availability of the service. So when we like tried to approach the security angle, we're very wary of systems that would like kind of put all of our eggs in one basket, right? So if we had like the public internet between 3 different sites, normally you'd say like, let's do a site-to-site tunnel and we'll just funnel all traffic through there. It's really great for like ensuring that everything transiting that path is encrypted, but it's not really great for like reducing risk, right? Because if one of those tunnels goes down, we're taking out entire data centers and we're just causing a lot of havoc. So the way we kind of approached everything was like provider agnostic. It tended to be like a distributed system as opposed to like centralized infrastructure we were standing up. And we just kind of built it that way because it made the most sense for PagerDuty systems. But then somewhere, I think it was like, 2014, Google put out like the Encore papers. And when we read those papers, we kind of looked at them and went like, those seem like very similar ideas of how we're approaching our much smaller system security for obviously a very large system like Google. So that kind of like encouraged us to feel like we're on the right path, and we wanted to explore this idea more and really help not just like the Googles of the world, but like smaller companies. How should you go about thinking about your security so that you don't end up in a situation where you have to re-architect everything and it seems impossible?
Sure. So actually that brings up two interesting points. I'll throw one little thing since you mentioned PagerDuty and reliability, and then there's something more interesting about security and resilience, but this isn't to do with PagerDuty specifically, but to do with pagers. I used to work at a consulting company a very long time ago. I don't want to say how long ago, that got acquired by a satellite communications vendor who shall remain nameless, even though this happened in the dim, dark reaches of past. I don't want to violate any NDAs I might have, but and one of their businesses was offering satellite-driven pager service. So back in the days, people actually carried pagers, and the pagers all went through a satellite. So there's pagers within hospitals, everything else. A security failure, people think about security as being, I'm trying to keep the bad guys out, but it also is, like you said, resilience, availability, et cetera. How do you protect against stupidity? And this was a case of stupidity. So this company leased, I forget how many transponders, something like 30 some odd transponders on a satellite, and they carved them up into thousands of pager accounts. And an engineer one night pushed a configuration for one of those accounts up, and not realizing what he was doing, overwrote all of the configuration on the satellite instead of just the one slot on the one transponder. So wiped out all the transponders, everything else. They had no mechanism to A, prevent him from doing that, security failure number one. 2, they had never tested how do we reload all of these configs? How do we get the old configs? And how do we reload them all back into the satellite transponders? Of course, for those of you who have done operations before, even when you test backups, they don't work. If you've never tested backups, you know where that story is going. It took them 5 days to restore service to all their customers because somebody had to go type in for each of those customers the transponder configs for each customer by hand, squirt it up to the satellite, type in the next one. So, security failure, SPOF failure, any number of things there. But that was, whenever somebody talks about pagers and reliability, that story just flashes into my head. But the bigger one I want to touch on a little bit, which most people wouldn't think of necessarily about talking about zero trust. You had mentioned that the tunnel between the two data centers was, if that tunnel goes down, you lose the whole data center. Right. One of the things you've been looking at here in Calico is how to do multi-data center, multi-region, et cetera, networking. I'm probably going to want to quote you at some point because I think the whole concept of if I force you through a single thing, be it a firewall, an IPsec tunnel, or whatever, it certainly reduces supposedly the attack surface. I think we could both argue that it really doesn't, but it has the appearance of reducing the attack surface. But it does become a huge availability problem. So one of the things we're looking at is making that connectivity both secure but much more pervasive endpoint to endpoint rather than scoped through small numbers or even one tunnel. So how do you think about trying to balance in this kind of environment not only the threat reduction, the attack surface reduction is probably a better way of saying it, with the availability? Because I think that is it's very easy to say, well, I'm just going to put all my eggs in this one basket. I'm going to make sure this thing never gets popped. I think you argue in here that it will. But even if you believe you can do that, there is nothing comes for free. There is an availability hit. So you want to talk a little bit about how you weigh those two and the way you look at that problem.
Yeah, sure. So kind of a few thoughts there. One, I always find it interesting where I think about when I approach security control mechanisms, I tend to think about them as there's a distinction between the implementation and enforcing side and the control plane side. And that's why we talk about that concept in our book. Because if you take PagerDuty system, even though we didn't have a centralized, say, firewall to manage who could talk to whom, we tended to treat the system at large as a centralized firewall because we used configuration management to just more or less blindly push it out to all the infrastructure. So I think it helps to separate those. It helps availability to separate enforcement from control, because it means that when things start failing, which they inevitably do, they fail in PagerDuty systems. It tends to be much more isolated failures, which also has the fun aspect of things are very just odd throughout the system.
Right.
I know when we were rolling out our IPsec mesh network, sometimes we'd have 2 boxes of a certain host type being unable to communicate with each other, but other boxes of similar host types were able to communicate. And ultimately it ends up being bugs in all of your control systems. And people were frustrated, understandably, because they don't like the network not to work. But I looked at that and said, well, that's a heck of a lot better failure mode than it would be for
losing everything.
Yeah, exactly.
Yeah.
So that's one thought. I think there's some interesting aspect here of as you push more of the enforcement requirements to hosts and endpoints, you are naturally increasing your risk that those enforcements will be subverted. And that's a valid concern. So the way I would try to guard against that is I think that moving workloads into containers gives us this unique opportunity to program something on the other side of the container boundary. And even if it's a little bit porous, it's better than just co-locating things. And then I think that once you have this kind of endpoint focused security mechanisms defined, you could then in your mind try to figure out, all right, how do I recraft the remote layers of security, but not as I'm configuring this thing by hand, but instead I'm materializing some configuration for it from all the endpoints I know that are sitting behind it. That's kind of the thought that I have. Now, whenever I mention that, people get weirded out because they talk about or you think about UPnP, right? Home routers just poking holes because something told it to. How do you authenticate that should be allowed? I think there's a path there with organizational stuff, because you could say there's some third system in the loop that has this database that's supposed to allow things through. So I think it's a little bit different than just letting an endpoint unilaterally say let me through.
So that becomes an interesting point. And this comes down to chain of trust, and I think we do want to talk about chain of trust in a minute. But let's assume for this conversation that there is a concept of a chain of trust, where at some level you can grant a certain level of privilege to an endpoint and know you're granting it to that endpoint. One of the ways I start thinking about the problem statement you just made about the remote endpoint and granting it access, I start wondering, is there things like mutual TLS that's tied to a specific entity or endpoint and for a specific policy? Is there benefit in doing that, not so much poking a hole, but saying if you're coming in with this type of certificate, you're going to be allowed to do these things. Do you think that's one possible way of addressing that remote endpoint problem?
Yeah, I think so. I think when we talk to different companies, a lot of companies are working on rolling out mutual TLS. And then like kind of where I see them trending towards is they look at configuring mutual TLS at every application is probably to take a Google term, toilsome. So instead, let's get like sidecar infrastructure that sits there and people route through that to get to the other side.
So delegating that process to a sidecar.
Yep.
So sort of like what Istio is starting to talk about.
Exactly.
As an example.
I think it's like a valid path forward. I somewhat worry about like the fact that TLS is very specific to like TCP connections, and what do we do about non-TCP connections?
But I think one thing you could start thinking about is if I've got that mechanism to do, all TLS is a way of having a certificate agreement over an encrypted channel. Today, that mechanism, the easiest way of doing that is over TCP using TLS, but I could take those same, if non-TCP became important, I think you could probably take a lot of those same mechanics and apply it to some other, tunneling encryption. You could apply that to say maybe transport IPsec or something else, but still using some of those same mechanics as that you were doing the certificate chain anyway. The same, you just apply those certificates to a different encryption algorithm.
Yeah, so interesting you mentioned like transport IPsec encryption, because that's what we did at like PhD system. Excuse me. I think like one of the downsides of that system is there exists no API for you to tie like the transport back to the application, at least in Linux today, which is a bit unfortunate. We actually found like some RFC that was proposing like how would you go about surfacing to the application, like spin me up a IPsec tunnel for my use only, right? Like that's the core downside in my mind of the system we built.
Right, I think, so you brought up an interesting point, and I do want to, since we sort of ventured into Kubernetes land without specifically mentioning it and talking about the sidecars, we should talk about that in a second, but I think one of the things you could do, if I'm not a session-based identifier, so TCP, of course, having a unique session setup. Anything else pretty much doesn't, right? It's a per packet association, and that really means a 5-tuple. The 5-tuple becomes, and for those of you who aren't familiar with 5-tuple, that's the source desk adder, source desk port, and protocol. That identifies a given flow in the network over a period of time. So when you hear network guys or security guys talk about 5-tuple, that's what they're talking about. We'll park multicast for a minute because multicast just blows all of this up. There's a point to multi-point encryption. But if we take, say, UDP flows or ICMP flows, if I have some kind of mechanism either in the forwarding path or as a sidecar or a set of rules somewhere, you could have a policy that says if I'm trying to get UDP port whatever between things labeled red to things labeled blue, then you could have a policy theoretically that says things doing UDP 514 between things labeled red and blue should be encrypted, and these are the keys that have been granted to you to use for that connection. Right. And then you would sort of replicate what TCP gives you. Yep. So TLS, but there is that level, there is definitely more, there isn't a direct API, but we're using you could use the fact that connection setup is almost an API, and then you just have to intercept that in some way and make the decision. Mm-hmm. So that might be one way to address that. Yep. Yeah, it's my joke lately has been for a long time is that we don't need port numbers anymore. Everything's in HTTP now, so we should just have one bit for the port. It's TLS or not TLS. But in reality, there's lots of things other than HTTP encoded protocols today.
Yep.
Let's talk about Kubernetes. So you mentioned sidecars. For those of you who, I think most people who tune into this have some knowledge of Kubernetes, but Kubernetes takes one or more pods, one or more containers and wraps them into a construct called a pod. And that pod acts as a single endpoint in the network. It has its own address, which allows you to do things like IP address-based 5-tuple filtering, but also has the concept of sidecars, where you can inject into that pod other containers that provide adjunct services. And one that Doug mentioned was some kind of sidecar to do TLS encryption of mutual TLS encryption. And mutual TLS basically means the client has a certificate, the server has a certificate, and in order for that connection to be made, the server has to get a valid client certificate and the client has to get a valid server certificate, so there's mutual trust on that connection. At least you can trust it as far as you can trust your certificate assignment mechanisms. So a sidecar is simply a container that you inject into a pod to provide some adjunct capability. So, but why don't we talk a little bit about Kubernetes, because you do mention Kubernetes here. You mentioned Kubernetes network policy and CNI implementations. So how do you think that Kubernetes informs or makes easier or makes harder this zero trust model? What's your thinking on Kubernetes from a lens of zero trust?
Sure. So I think we're at a crossroads here, and so I think our hope with the book was to tip people that are moving towards Kubernetes towards a better future, as opposed to what I think somewhat cynically might be the path of least resistance, which is, well, we'll just make a big shared network and everything's just being scheduled throughout it. And oh, by the way, now they're multi-tenant, so who knows what type of security guarantees we can make about that system. I think Kubernetes and all these container schedulers, the interesting asset they give you is some again, third-party knowledge of what should exist in the system. And you can then leverage that knowledge to spin up tighter layers of security just kind of computed off of this source of truth. There's a risk associated with that, right? Because if anyone can get access to the source of truth, then they could just turn down all that security layers. But I think that's a more tractable problem than trying to go application by application and securing it.
So you're basically saying in this kind of environment, you can distribute the enforcement of policy, but you need to protect, if I rephrase what you're saying, protect the control plane that actually distributes what that policy is and what those actions should be. So you need to, protect your control plane and reduce the footprint and scope of your control plane within reason.
Yep, exactly. And the nice thing about I think Kubernetes in particular, right, is that control plane is wholly separate, but it gives you this programmatic API to discover the state of other systems, right? So you can imagine putting control plane systems in between the actual queue workers and downstream systems, but it's all being informed by the API.
I mean, one of the things that we've seen, and we've actually talked, and so we obviously here at Tigera, we do a lot of work with Kubernetes, we work with other things as well. But one of the things we do talk to customers who have security concerns, especially in private cloud, where this may make more sense, is running their Kubernetes control plane over, say, the management network. So in a lot of private cloud infrastructures, you might have a prod interface, which is your worker interface on your nodes. You also probably have might have a management interface, which is where you actually manage the nodes from. And given the way Kubernetes works, it's actually fairly easy to put the Kubernetes control plane on the management interface. And then you have your SSH jump boxes or whatever else you've done to sort of protect that network. And you can write lots of policies because there's no dynamic things going on there. It's basically every node has a kube agent, has a kubelet. Kubelet needs to talk to etcd or whatever else, the API servers. And that's about the only thing from a Kubernetes standpoint you need on that network. That becomes fairly tractable to secure. and not have to. It also prevents, we've seen at least in one case, where somebody tried to get too aggressive to protect the Kubernetes interface on the production interface. They cranked it down maybe a little bit too much and cut themselves off from the Kubernetes API. Of course, you need the Kubernetes APIs potentially to fix the problem, which you can't get to anymore because you just diked yourself off. So, having, if you're going to get really aggressive on security, having the control plane taking a different path than where you're putting your production policies has some reliability benefits as well as security benefits. So you talked a little bit about Kubernetes network policy and implementations. Do you want to go into how you view Kubernetes network policy, specifically how the changes in 1.8 adding egress policies, how that affects your view on using Kubernetes network policies on Kubernetes?
So I don't have a ton of hands-on experience with Kubernetes, so I can give you the high-level understanding of that. So I think some of the interesting things I see in the Kubernetes network policy when I look at it is it tends to approach policy, the way I describe it is symbolically, right? You label endpoints and you don't talk about their actual physical location. So that's very neat. It's similar to say Amazon security groups, which I do have more experience with, right? Where you could define security groups that say I can access this other thing referenced symbolically. And then just behind the scenes, obviously, systems are figuring out how do I actually populate or tie that back to the infrastructure. I find that a good path forward. It seems a lot to my brain, a better approach to managing your system than trying to think about it in terms of okay, well, if I want to have security control here, I need to define a subnet and make rules between subnets. I think there's still some value in partitioning networks like that, but I don't think it's at the workload size, right? I think it's at an organizational size.
Okay. Maybe different clusters or something along those lines.
Yeah.
All right. Before I get off this, a shameless plug, you did mention Calico in the book. What made you mention Calico in the book?
Sure. So that was in a section where we were talking about the benefits of filtering and trying to take a first principles look at it. And so we talked a bit about filtering traffic coming into you, but a lot of people stop there and they just say, well, anyone can talk to anyone going out. Because everyone's guarding their own stance. And we think that's a missed opportunity, especially when you are just calculating all of this enforcement rules. And so Calico is a good example of what we call bookended filtering. I think you all ended up on a similar term, right? Where you say, well, if I know party A is talking to party B, party B can certainly block access from anyone not A, but A can similarly block itself from sending to anyone that's not B. And usually when you look at it, you tend to think oh, well, there's not a lot of value there. And we struggled a bit trying to figure out what the value was. And the term or the analogy I came up with to try to talk about it was I think there's some amount of herd immunity in the system at large if a initiator of communication knows who they should or should not be talking to and can self-enforce that versus just expecting all the receivers to limit people because it basically can protect someone who's let their guard down from bad actors in the system.
So you're basically saying egress filtering that Calico does as sort of a vaccination against propagation of disease within the herd.
I think so. Take it to the limit. Obviously, we're assuming that if someone can get root on a box, obviously they can take down that egress filtering. But assuming they don't have that position, there's some guard against someone else being in a weird state.
Sure. And then there are things you could do in that case, using SE Linux or other things to protect that. So even if you have root, if you don't have the right SE Linux permissions, that becomes more difficult to do. But also, fine, you've now shattered the protection on one side, you now have to go do it on the other side as well, right? And that's the nice thing about these kind of models. The way we talk about it is I'm not only protecting myself against everyone else in the cluster, I'm protecting the rest of the cluster from me, which is similar. But I like the herd immunity. I think I'll probably shamelessly borrow that in the future.
It's kind of neat once you like start looking at that idea, you start seeing it in other people's designs. I watched a talk from Amazon's like VPC team a while ago where they were talking about like how does VPC work under the covers, and it's a similar idea, right? Like the hypervisor is receiving a packet that's supposed to go to some other host in the system. It's all multi-tenant, and what do? First thing they do on that host is they do a bunch of sanity checks. Should this thing even go where it's going? And then they ship it. On the other side does the exact same thing in reverse.
Yep.
Yep.
Cool.
Good idea.
So one thing I caught up here earlier was chain of trust or other terms for this, but how do you view, we talked about, assigning potentially credentials to endpoints. Obviously you have to do that in some manner such that you can rely reasonably. I think one thing in a practice in security, very often security teams, and you mentioned security makes you go slower. I'm not sure, and that's one of the things people always say, well, security slows us down, therefore we don't have time to do this. We're all startups, we're all trying to go 1,000,000 miles an hour. I think one of the things, instead you look at it and say security makes you think more, and you can you do need to think about it all up and down the stack, but hopefully if you put the right primitives in place, it becomes easier over time, right? You don't have to keep on reinventing the wheel each time. But the other thing is, I've mentioned this before to many people, if people don't take time to understand the threat environment they're in, and the threat environment could be bad actors, it could be someone shipping bad code by accident. If you don't understand your threat model, the inclination is to turn the dial to 11 on the security posture and superglue it in place. And that then makes the platform potentially unusable, and people will find ways around it. And as an ex-security practitioner or on the operations side, I hate that, because what that means is now developers are smart, developers will find ways around my security policies, and then you're taking traffic, other things are flowing outside of the swim lanes I've created for them. It's unmonitored, I don't know what's going on. I'd much prefer to be a little more relaxed, or a lot more relaxed, and encourage people to go through the paths that I've actually intended for them to go through so you can monitor it and that kind of stuff. But the key in order to be able to do that is to understand your threat posture, right? From any given security tool should make it harder to subvert or harder to achieve the negative goal than the cost of, than the value of doing that, right? So if something is going to cost me and is going to render me N dollars if I get it, some piece of data I'm exfiltrating, all I really need to do is provide, as long as I have a holistic view of this, a security posture that makes it more expensive to get that data than it's worth, for example, as a bad actor. So anything I'm looking at, what I need to look at is how much I need to protect this. So for example, if I'm giving a credential to an endpoint that is going to be the thing that approves all ATM transactions in my banking network, that's a fairly high risk component. I need to think very carefully about how I assign credentials to it. If it's a normal worker doing front-end processing, it maybe has a less of a threat endpoint, right? So when you start talking about assigning credentials to endpoints, how have you given much thought to the mechanisms or the way you think about doing that chain of trust? So I'm going to be granting this thing a given credential. What goes through your mind? What do you think about as you're coming up with a system to do that?
Yeah. Definitely thought a bit about that. I think there's a few key points. One is having really good rigorous attestation on the endpoint that you're giving that credential to. I think having really deep monitoring around just blowing up when credential copying can occur. That's something that like stood out to me when reading Beyond Core papers, was they talked about like if they would know like specifically which credential goes to which endpoint, and because they had some proxy that could like tie those two together, if they ever saw a credential show up on a different endpoint, they would just like cut off that credential immediately, and then get people to go re-credential to remediate. Seems like a great practical idea, right? But when we do it, we don't do it because like installing credentials is a pain, and we just we don't want to deal with the slog that is like credential rotation. So that's kind of like the third thing in my mind, is like frequent scheduled credential rotation is like kind of good. It's good lubricant for making sure that your machinery doesn't get like jammed up and you fall back to the simpler solution. And then that once you get that, right, then you go like short-lived credentials. Why don't we just make this every 18 hours instead of like a year or something like that?
Or even shorter than that. Once I've got an automated mechanism to do it,
right,
you can crank that TTL, if you want to think of it that way, down.
Yep.
The thing I find interesting when you start talking about this, we're rediscovering all the problems. Nothing is new in this industry. So wasn't a perfect system, but a long time ago, back in the 80s, we created a system called Kerberos to grant tickets or certificates to things based on the function that they wanted to do. So if I wanted to talk to X, I presented my long-lived certificate or ticket to a Kerberos ticket granting service and say, I want to talk to X, and that ticket granting service would decide if that was good or not, and then hand me back a short-lived certificate to do that.
Right.
We tend to repeat the same problems and the same solutions over and over again in this industry, which I find mildly amusing.
And I think that's generally my thought, Evan's thought too. It's like all of these ideas have been explored before. We just need to apply them in a really good way.
Yeah.
And I think like if we were to wind the clock back, why did those not catch on? Maybe it's just because we didn't like actually make a very good interfacer experience for the end user. And that's what we need to do to like get buy-in to that.
So I think that's one. Kerberos was never particularly friendly, but again, crypto was much harder back then. But I think another one, the enterprise community had fully bought off on perimeter. If you're in the perimeter, you're safe and you're trusted. If you're outside the perimeter, you're not trusted. And if that's the case, then why do I need fine-grained credentialing? Because if you're in the perimeter, you're trusted, and if you're not. Right. So therefore, making an investment in something like a Kerberos environment, Microsoft does use it for Active Directory, but it didn't take off in broad spectrum because I think partly people made this assumption, I'll just do the security at the perimeter, which we've now learned is a fool's errand. So we didn't make it easy. Places where Kerberos did take off were more universities and research organizations, which by their nature had to be untrusted environments. And that's what you see. Where did Kerberos take off? Universities, research labs, that kind of stuff versus enterprises. And I'm thinking part of that was because the enterprise community went off on this firewalls will save us from everything, and we now know that's probably not the case. Yep. So, what would you say, a couple of questions here. If somebody wanted to start approaching a zero trust model in their infrastructure, what should some of the things be? How should they design their network and their infrastructure to be ready for zero trust or help move themselves down the road of zero trust?
So I think it all depends on where they're starting. If they have a big system, obviously they can't just shut it off and rebuild it. In that case, I probably would advocate, go for like the most valuable systems and try to, ironically enough, building a zero trust perimeter around those systems and grow it.
Okay.
I think that's the most practical way to do it.
That's actually what we see when we've got customers going that way in Tigera is, say everything no one's starting greenfield, right? So it's that idea of we'll start it here and then we'll propagate as we go.
Yep, exactly. And I think like in that scenario, really the key difference you're doing is you are, building up this database of like expected state, really like you said, doing the legwork to understand what's in that system and why it behaves the way it does, and just codifying it in a better way.
So do you have any ideas on how people can do that to codify? Obviously, if they're starting new in this cloud native or Kubernetes type environment, the microservices, the containers, whatever, are already annotated in order to drive Kubernetes. Already know what this thing is and what it does and who it should talk to is pretty easy. But that legacy model, you know, that old code, do you have any ideas on how people can go back and try and codify what that thing is supposed to be doing and develop that database, if you want to call it that, or model of the application such that they can bring that chunky, you know, multi-headed beast that is that monolithic application into a zero trust model?
Yep. I think it's the very like unsexy work of inspecting network flows, classifying them. Seems to be what a lot of people did. It's what Google did, right? When they wanted to go with Beyond Corp, they just basically started logging all network traffic and like putting in rules that said, oh, we know what this is, and let's, you know, drive that down until we can get to zero, and then let's slowly pull people over into a different network and see if like this works well for them. They also did a bunch of like simulations. So I think if we had like a really nice pony, you just like install agents on everything and it would inspect your traffic for a week and then come back and say like, well, clearly everyone's doing DNS. So I'll give that allowance and we'll slowly build things up and humans have to dig through it. Honestly, sometimes I kind of wonder, do you get the same benefit if you just let some like vendor do it for you, or is really the benefit here like you going through it as an organization and like understanding what you have in the end?
Yeah, I think that's because there's another risk too. The assumption if you're you know, using current network flows to decide if what the application needs to talk to, you're assuming the application has not already been subverted intentionally or unintentionally. Otherwise, you're just going to model the bad behavior and say that's allowed.
Right.
A vendor is not going to have any chance of figuring that out. It's hard enough for the organization because the guy who wrote that code may have left 10 years ago, but at least you know what that application's supposed to be doing. And by understanding it, you can say, well, why is that thing making this connection? That shouldn't be. A vendor is going to go, it's making that connection. It doesn't know what you're supposed to be doing. So I think there is a very real risk of having people that don't understand the business model, and a vendor will never be able to do that for you, making decisions. Is that a good flow or not? And, you know, and if you don't understand, I think one thing that comes across when you start thinking about this is if you don't understand what your infrastructure is trying to do, you're never going to be able to get to the, you know, you can't have, maybe, is it a true hypothesis? You can't support a zero trust knowledge if you have network, if you have zero knowledge.
Yeah.
You have to have knowledge in order to support this. And if my knowledge is embedded in a vendor somewhere who has not complete knowledge about what's going on, are you setting yourself up for a failure here?
Yep, I think so. And I think like if you take that kind of leads you down the thought process of, well, if I need pervasive knowledge of my system, who knows the system best? Probably the people that built it. So therefore I need to like grant them some amount of like autonomy to help define our security policy. We can't just be like, the security team is going to introspect this thing and, you know, continually react to someone else changing the system configuration.
So you're saying you need trust in your organization in order to support a zero trust environment. You need to trust the people and the functions in order to.
I think you need some degree of trust.
Yeah.
In the people, right? But then you also need to watch them and like actually vet and making sure that they can't do like actions on their own. So like Slack does an interesting thing here where like when anything like kind of comes across like as a something's flagged by security, they'll like kind of classify it and say like, all right, well this is low risk, but we want to make sure that it is the person doing this. So they'll ping someone and have them do a two-factor auth. You know, if it's higher risk, then they maybe ping like a peer and have them like validate it. You know, there's like gradients here of trust that you can use to make sure whether or not, or make sure that people aren't like your threat that you're letting your guard down against.
So I think the one thing that also comes into some of that maybe is, as you said, trust. You need to have some trust in your people, but you also need to make sure they're doing the right thing. That's maybe where things like tiers of policies can come in, right? The developer can write policies that affect their app, but if it's something that, say, is a compliance issue, a PCI issue, or whatever else, the only people who can render that kind of policy are the people who are responsible for PCI compliance, for example, right? So the ability to tier the kind of intent of the network is a useful tool here, maybe.
Yep.
Cool. So what was the most interesting thing that you discovered? What surprised you most when you were writing this book?
Sure. I think the thing that surprised me the most is it's a book about network security, but we have a whole chapter on like application security. And we fairly quickly identified that, like, you know, if you didn't have some mechanism for ensuring that your applications are actually trustworthy, you could like have all of these control mechanisms in the world and someone subverts it through there. So like having a well locked down build chain is critically important for even just like the system security. That was probably one of the ones that jumped out to me, and I have since talked to people who have done like red team exercise, and they're like, "Yep, we go straight for like build systems, build farms, because they have access to everything, and there's like remote code execution if you just wait a while." So.
Yep. Yeah. The Manchurian candidate application.
Right. Which makes it interesting when you think about a lot of startups today build themselves off of SaaS providers, including CI. So maybe they need some guidance then, and like at what point do you get wary of like the SaaS provider and say we need to bring that in-house?
So SaaS provider is another one. Your developers go, "Oh, here's a Docker container that does exactly what I want.
Right.
I'm just going to include it in the build." Do you have a process for vetting containers and that kind of stuff? Because again, theoretically the developer could say, this is only allowed to talk to A is only allowed to talk to B, and that container may try and talk to C, and then that's, you can catch that with the policies you wrote around it. But you also have the concern of what if it talks to B but is doing something you didn't intend for it to talk to B to, right? And that's maybe where providing, say, using Istio or something along those lines, policy protections at a higher level, like, well, gee, why is this making this kind of API call? Right. In B, I didn't expect it to be making that kind of API call. But,
yep. And the developer angle is an interesting one too, because it's like a missing tool, I think, for us is much better dependency management tooling. Right now, like if you actually care about security of your dependencies, you end up buying like a artifact storage system and then having a bunch of people just like copy from one artifact.
Repository to another, right?
And
run
we
your
say
own.
like they're vetting it, but really are they vetting it? Like,
or are they just copying it over? Yeah. That's very true. That's very true. So one of the things that I've always found interesting when you make major shifts in organizations, we saw this when we did ERP a long time ago, is, and I think this is maybe another one, when you're actually introspecting a major architectural shift. In this case, I'm not going to trust my infrastructure versus the infrastructure being trusted. That has the likelihood of being an organizational change, not just a technology change. So when you start thinking about organizational change, you first have to understand where the organization is if you're going to change the organization. So have you seen that kind of behavior, that as people start moving towards zero trust models, they rapidly discover they have to figure out how the organization works and how the organization has to change in order to implement the zero trust model? Is that something you've been seeing?
I think so. I don't have a lot of like direct experiences, but I do generally see like, you hear about it in like say the DevOps movement. I don't know if you all heard that, but like this idea that in order for an organization to be successful in today's marketplace, you need developers and operations like thinking empathetically about each other's needs and working together. I see that idea kind of like it's already, you see security people saying like, yeah, I could actually leverage a lot of this knowledge and shared understanding workflow to better do my job, and then ultimately we're probably going to see like the same thing with the networking side, right? Like having your network be collaboratively defined. I think that's where we end up going. And then the great thing about this is, like, at one point I told people I feel like a lot of my job right now is just thinking through like workflows, which obviously we've got like business analysts thinking through like business workflows. But like anytime we sit down to make a system, right, you have like production, you have somewhere to test just before production, then you have like a development experience, and a lot of the requirements in each environment are very different. And so figuring out how do you enable a group in your organization to be effective at each stage in that pipeline is like important for creating this like zero trust production environment, which is really what you want, right? You maybe want a non-zero trusty environment for development, but you probably also don't want a lot of things that you care about.
Cool. So I think you've been on the spotlight for most of this. I've been asking the questions. Do you have any questions or comments from your side?
Sure. What's like your guys' biggest pain point getting people to adopt, say, Calico?
So I think it's come we get intersections at various points in the journey. So for early on, a lot of people were trying to solve the networking and scale problem. And policy was an afterthought. You know, we go in and we talk about, yes, we can, you know, help you network hundreds of thousands of endpoints and that kind of stuff. And Calico is half networking and half policy enforcement, right? And that networking was the attraction early on, mainly because the place the industry was coming from, say an OpenStack, was so incredibly painful that people needed something simpler. And you talk to them about policy, say, yeah, that's great. Right now, I just need to get things talking to one another stably. And then what's been interesting is people went down that adoption path. They go down that adoption path, and then some number of months later, you know, all of a sudden, gee, they now need to meet the security teams, CISOs, checkoffs, et cetera. And say, you were talking to us about policy before. You know, let's have a conversation about policy. So that sort of organically policy comes in. I think there's other organizations, especially ones that are more public cloud oriented, their initial request is about policy. Because frankly, if you're in GCE or Azure or something along those lines, the network is already taken care of for you. They have native CNI plugins, et cetera. So their intro is, we need to apply policy. And once those organizations start going through that path, where they end up with is, yeah, I got this great policy model now for my new applications, but I need to access that Oracle rack back home. How do I do that? Because I've got a bunch of random IPs over here now from Kubernetes. I can't update the firewalls. So how do I do that legacy bridge back to whatever that legacy platform may be back in the private data center? It may be I'm doing this in the private data center. I've got these legacy components. And that's one where we spend time with folks, and there's mechanisms to do that. We've got quite a bit of tooling around doing that, but there is a certain amount in that case of telling the network security folks that they have to let go, that this is not going to really work well with the legacy firewall, because the constellation of endpoints they're going to need to access that is too dynamic. You know, how you never, you know, you hear from probably everyone, you know, I can spin up workloads in 30 seconds and the firewall update ticket takes a day and a half on a good day. You know, what's the point of running Kubernetes if it takes a day and a half to update it? You know, I do a blue-green shift, or I do an auto scale. So coming back and working through it with the network security guys to prove to them that the security that can be provided in an environment like Calico, where it's endpoint-based and policy-driven, can be as secure, if not more secure, than the legacy firewall, such they can then say, okay, I'm going to treat the Kubernetes cluster as a trusted endpoint rather than the individual within the firewall. Right. And that's where things like your egress policy conversation really comes into form, because I can't necessarily put Calico on some legacy appliance. Right. So then the filtering really does become egress based in order to allow that to happen. So that's really one of the things where that belt and braces, okay, the firewall is going to say, I'm going to block everything, I'm going to allow all the legacy stuff in I did before, but I'm going to treat the Kubernetes cluster as a single trusted entity, and then rely on the Kubernetes cluster to provide that egress filtering.
Mm-hmm.
So that's one, and logically it makes sense, but it's really hard for people for security guys to do the, okay, I'm going to allow this /16 through the firewall.
Yep.
That's a evolution. So, it's for them, and I think the only people who end up being really unhappy in that is maybe the firewall vendors, but that's not my job to make them happy.
Mm-hmm. So that pain point kind of sparks in my mind the interesting intersection of infrastructure automation tools and letting you do things that you couldn't do before. So I've been playing a lot with Terraform. Use that. And you could imagine a scenario where you had a Terraform module that's reconfiguring firewalls for you automatically based on knowledge it has of Kubernetes, right? So you get this again, kind of that triangle, right? You get some third party in there,
sure,
helping facilitate communication.
Sure. Question is then how fast can that fire? Is that you're going to do that for the whole kube cluster? Or you're going to do that for workloads, but then how fast can you fire that? There's but yeah, it's an interesting. And then you have to protect that data source, right? Because that data source can now drive behaviors.
Yep.
So, anything else? Anything that we didn't touch on that you think is interesting?
How much time do we have?
A couple more minutes.
So one thing I threw at you all, I don't know that we can cover this in a couple minutes, but it is something that's on my mind a lot, is we talk about organizations, networks, and securing them, but then home networks are kind of this tire fire of pain.
Right.
So is there a future where you imagine zero trust principles being applied to a home network, and what does that end up looking like?
So I was thinking about that a little bit when you raised that one is how do I trust an endpoint in the home? Assign a credential to an endpoint in the home coming back into the cloud. But there is the whole concept of the home network as its own domain rather than a host for something that's coming in, talking to something that I trust. So yeah, what's your thinking on home network?
I feel like all of these companies that are starting to do mesh networking are in a really interesting position to reconfigure everyone's home network. So I, having knowledge of this stuff, went off and bought Ubiquity gear, and I'm starting to make VLANs and put things on different segments, but no one's ever going to do that in their house. So it'd be very interesting to see someone in Euro be oh yeah, I just made your network more secure by reconfiguring the entire thing under the scenes for you. Oh, and I can point out to you that that webcam you bought that was super cheap is full of malware, and you should probably not use it if you care about it. I think there's I'm hopeful that they will do something like that, because that would be a dramatic step forward for not just home networks, but security for the internet ecosystem, essentially.
Sure. The interesting thing you mentioned about webcams, you had mentioned a large company earlier who produced a set of papers that sort of talked about zero trust within an organization, and now it's as far as I'll go because I'm about ready to discuss something. Early on, I was tangentially involved with that project, and the thing that opened my eyes, normally in an enterprise, people protect the phones, the security cameras, the door access control system. Those are sort of the key things that they protect. It's the core, because that runs the business. And computers and everything else, people's laptops, etc., are less trusted. They flipped this entirely on their head and said, we don't know what is in the kernel on those phones, or what's in the kernel on that door access control system, or that webcam. So we're going to treat those as completely untrusted. They're going to do their job, but they're not going to have any access to the rest of the infrastructure because we don't trust them. We know what we put on our users' laptops or the servers, so those are actually more trusted. So it was an interesting flip in my mind when they said these things are untrusted but necessary,
right?
Whereas everyone else trusts them completely and treats the user's laptop. That requires you to actually understand what goes on your users' laptops, right? And understand the kernel and all that. Most organizations aren't going to do that, but it was interesting. and prescient, because at that time no one was talking about publicly about malware in phones or in webcams. Now we're all talking about it, but this was years ago, and they were saying, no, we just don't trust these things. Mm-hmm. So I think that was an interesting, and those things are, like you said, running all over the home today. So being able to identify that set of webcams and should only be talking to this one thing, and I'm going to enforce that. That would be an interesting model. So there, for all the people who are listening to this, if you're looking for a new startup business model, maybe it's zero trust and auto configuration for the home network.
Yeah, there's something there.
There's something there. I agree. All right, Mike, anything from you before we call this a day?
No, I mean, I think this was super helpful. And, I think the big takeaway from your book that really got me as an engineer is that it's not just the malicious actors, the opportunistic hackers or professional hackers, but it's the people you trust the most that can actually do the most damage in your network, in your infrastructure. So, I mean, it was a great book, great read. And I just iterate kind of what Chris said before, which is if you haven't read Doug's book, it's available from O'Reilly, both in print as Chris showed, also online. Be sure to get it because it's a great read and very insightful in a lot of ways.